Hi everyone, this will be your video for radians and degrees, and we're going to learn how we can move between both of these units and how we use them both to measure angles. So we do need to just figure out first what is a radian. And again, we can kind of reference this as a unit of measure. And a radian, we have this full definition, and it's defined by the angle whose arc length is equal to the length of the radius. And that sounds like a lot going on right here, but basically it's saying that it's one angle that would measure the length of the radius, the arc length, and the length of the radius. So, there's a lot of words getting thrown around here, but what I want you to realize, it's a unit of measure, just like how we would use degrees as a unit of measure for an angle measure. So one important thing that I want you to make sure that you highlight from this page, and this is something that will come back many times, you're going to see it a couple times in this video, is that in a full circle, we know that we have 360 degrees. In radians, we can say that we have 2 pi radians. So here we have some guided notes. You can follow along with the PDF posted in the Google Classroom, or also the Google Slides where you can fill it in digitally. So let's just talk about some basics that we do already have filled in here, some vocab words if you want to call it that. And we need to talk about just angles in standard position. So we have a couple different identifying terms here. We have something that's called a vertex, and that's the point, or almost the part that's opening up. This is your center of your angle, the vertex. We have an initial side, and our initial side will always lie on this positive x-axis. Okay, so it's going to sit here, and think of this like opening upwards to our terminal side. So if you can really imagine these two rays, they were lying on top of each other, and one of them is opening up to become this terminal side. Now just keep in mind what like terminal means and initial, and that's going to help you figure out the placement. Initial means beginning, if it's like an initial reaction, it's your first reaction. When we think about terminal, if something is terminal, that means it comes to an end. So that's our ending position. So where do we end up? On our terminal side. So when we have our angles in standard position, this is on a coordinate plane. So there's a small little typo here. Just make sure you change that to coordinate plane. And we're talking about an angle whose vertex is at the origin and the initial side is the positive x-axis. So we've talked about this earlier. If you do ever have a function, an angle that is referenced as being negative, what that means for us is that now instead of rotating upwards, and I've zoomed in a little bit here, instead of going upwards, this is our positive direction. If it's negative, it's actually saying we're starting at our initial side. We're going to be moving towards the negative. So we're going to be moving clockwise. Okay, so this is a really important idea to really wrap your mind around. It's positive when it's opening upwards, and it's negative. And for instance, you could see that this terminal side, and I'll draw it in a different color, it was right here, and then it moved downwards in a negative direction. So there's a difference here, and then it ended up on this terminal side. So let's talk about degrees and measures here. All right, so let's move down to this circle that's on the lower portion of this page, and we're just going to break this up either into degrees, and then later on we're going to break this up into radians. So just so we can get this nice solid foundation of the circle in degrees first. So we always want to start at 0 degrees, and we start at our initial side. So remember, our rays are kind of lined up here, and they're going to be opening upwards. So that means that at my top over here, we have 90 degrees. If I were to continue to open upwards like that, my next angle would be 180 degrees. If I continue to go again, that would be 270. And then you can see the very last one would be, I'm adding on another 90 degrees, so I'm going to end up with 360. So that's in the same place that 0 was, because we start and end in the same place. So we can fill in over here that degrees in a full circle is going to be 360 degrees. We know that if it's a quarter circle, and we can even see by the way that our circle right here is cut up, a quarter of it's going to be 90 degrees. A half circle, that's actually the one I already have an arrow for right here. We went halfway through our circle and it was 180 degrees. And then a 3/4 circle, so we went half. We can go a little more, so we're down at this angle down here, so 270. All right, so let's move on to the next page. So I'm just going to do a couple of these top examples with you, and they're asking you to draw an angle with the given measures in standard position. So this is just going to be a little bit of estimation, just knowing what we have at each quadrant. We had 0, 90, 180, 270, or 360. So you can remember that those are the values that we're going to be having here. So if we're trying to find, for instance, number 1 is asking us for a 70-degree angle. So we'll do this in red. So remember, my vertex is always at the origin. My initial side will always be on this positive x-axis. So this is my initial side. And it's telling me that it's a 70-degree angle. So I know that if I were to go vertical right here, if I were to open this up all the way, I would be at a 90-degree. So I know it's just going to be a little bit less than that. For instance, this is going to be incorrect, so don't write this. But if I were to do it like this, that's directly in the middle of 90, so this would be like a 45-degree. So we need to make sure we're estimating as accurate as we can. I know it's going to be closer to 90, so somewhere around here would be about perfect. So there's our 70 degrees. So let's erase what we don't need. Get that out of the way. And then we also do need to figure out what quadrant this is in. So remember, we start with quadrant 1 when everything's positive. This is quadrant 1. This is quadrant 2. This is quadrant 3. We go just like how our angles are opening. And then we have quadrant 4. So let's look at another one here. I want to look at number 4. So number 4 is now asking for a 500-degree angle. I also just realized we never filled in our answer before. We're in quadrant 1. So let's just pop back up there real quick. Quadrant 1. All right, now back to number 4. So number 4 is asking us for a 500-degree angle. So I know right off the bat, this is where 0 is. This is also where 360 is. So if I'm starting here, I can go all the way around. Once I get to this point, I'm at a 360. That's my full circle. And then we still need to get to 500. So we just need to figure out how much more we need to go. So you could do 500 minus 360 since we've already taken 360 degrees. And when we do that, we get 140. So we're going to estimate where 140 is. So I know it's going to be past 90 because this is 90 up here. I know it's not going to be past my x-axis again because that's 180. So we can imagine it's going to be somewhere a little bit more than halfway between these two values. So somewhere maybe we'll estimate it about there. Draw our terminal side. There's our initial side. We should have wrote that first, but there we go. We have our initial side, our vertex, our terminal side, and a 500-degree angle. One other way, also the quadrant. This one ends in quadrant 2. So one more example from this top part. We'll do a negative angle, and we'll do number 5, negative 15 degrees. So again, I know that this is where 0 is at. This is also where 360 is. You don't have to fill these in each time, but this will help when you're trying to figure out, especially your quadrants. So we want negative 15. So that means if our initial side is on our x-axis, we have our vertex here, and we're now going to be moving in a negative direction. So negative directions are downwards, okay? So we're going to be moving in a negative directions. We're only going 15 degrees. That's a pretty small amount when you think about how this whole circle is 360. So we're just going to estimate it as best as we can. Also clearly showing that we went into a negative direction. And then we can just label it that this is negative 15 degrees. Now our terminal side ended up in our 4th quadrant. It ended up down where everything's positive x and negative y's. So this is our 4th quadrant over here. So we're going to put a 4 up next to our Q. All right, so let's move on. So we've been talking about degrees. We just worked with graphing degrees. Now we're going to talk about radians. and how they relate to each other. So we did talk about this earlier very briefly, that a full circle will have 360 degrees, but it'll also have 2 pi radians. So put this in a better color for you. So we're going to have 360 degrees, and that's equivalent to 2 pi radians. Okay, so what we know is if we had a quarter circle, and this is stuff we found out before, it was 90 degrees. So that's essentially like taking a quarter of 2 pi, okay? Just like how we took a quarter of 360. So 90 degrees will be equivalent to pi over 2. For a half circle, we knew that it was 180 degrees because we took half of 360. So if we take half of 2 pi, we're going to end up with just pi, and that'll be our 180 degrees. And then if we're looking at a 3/4 circle, okay, so that's 270 degrees we decided earlier because that's 3/4 of 360. We're going to do the same thing to 2 pi. We're going to take 3/4 of 2 pi, and we're going to get 3 pi over 2. So what you can remember is that you don't need to do these conversions a lot, but we can fill in this circle almost the same way, where we start at 0. Now we're moving to our 90 degree, which we can write as pi over 2. We're moving to our 180. Remember, we're moving in this direction. Moving towards our 180, so that's going to be pi. Moving down to our bottom degree here, or bottom measurement, and that's going to be 3 pi over 2. And then to the very end, we know 360 degrees, or a whole circle, will be 2 pi radians. So when you're filling this out, remember they're equivalent. We're not learning anything new. The values aren't different. It's a different unit of measure. It's almost like comparing inches and centimeters. You're measuring the same thing. You're measuring a length in a different unit. Same idea here. We're measuring the same thing. We're measuring an angle using a different unit. So one little review I want to go over before we end this page is just circumference and how we can use it with our radius. So we always learned that circumference of a circle was 2 pi r. Okay, that's circumference. And when we need to focus when our radius is 1, and this is going to lead us in a little bit to next week too, but you can see that when your radius is 1, we can fill this in as 2 pi times 1, and we would just leave it as 2 pi. So the circumference of a circle with a radius of 1 is 2 pi. And that kind of like pulls together with the amount of degrees we're working with. Okay, so the last thing I want to show you guys is how to convert between degrees and radians. And this is just how you would convert, like I said earlier, maybe between inches and centimeters, or between feet and miles. You have a conversion factor, you apply it. So our conversion factor, it has to be something that's equivalent. So we know that 2 pi and 360 degrees is 2 pi radians, and 360 degrees, these are equivalent. And that's how you make a conversion factor. It just has to be an equivalent fraction using 2 different units of measure. So we have 2 pi radians over 360. Now what you'll notice is that this can be reduced, and we already have that on our screen here for us. And when we reduce it, we can see that it will end up just being pi and 180. So the thing you need to know is which one of these should we use. So what you can remember is that what you want should be on top, and what you have is on the bottom. And what's going to happen is the unit of measure that you already have will cancel out, and the one that you want will be the only thing left. So this is if you want degrees and you have radians. Okay, so just be careful. You want to have your degree or your radian cancel. So we'll do 1 or 2 of each of these. So we're going to rewrite this 60 degrees in radians. So I know that if I have degrees, I'm going to make sure that 180 degrees is in my denominator and pi radians is in my numerator. We multiply across, we get 60 pi over 180 radians. And then you can reduce 60 pi over 180. You don't even have to use pi as a value here. Pi can stay as similar to like a variable. It can stay pi. So when we do this, we actually get 1/3. So we would get 1 pi over 3 radians. Okay, so that's how we go from degrees to radians. Let's go in reverse here. If we want to change number 5, we want to change this to degrees. So what we want needs to be on top. So we want degrees, so we're going to put 180 degrees on top. And what we have is radians, so they're going to go on the bottom. You can see here that your pi's are going to cancel. And you would just basically have to do 7 times 180 divided by 4 because our pi's canceled. And we'll get a value here, just plug it into a calculator and you get 315 degrees because that is the unit of measure we're left with.